Hello everyone. We will begin practical sessions to understand the language better. Let us write, compile and run a program. We will go over the program, the tools needed to run it, the compilation process and file formats in this session. The only way to learn a new programming language is by writing programs in it. Let's get started with the Hello World program right away, simply by following in the footsteps of Kernighan and Ritchie. So this is the right side, your program is presented. Before going to write a program, we will get a question like where we will write the program, what are the tools required, right? So we'll move on to the tools part. In this session we are going to use the editor. Editor is an editing tool to create the or edit the source code. So we are using Visual Studio Code, a source code editor provided by Microsoft. It is installed in the system already. Then for the compiler we are using GCC, GNUC compiler. Yeah, the system is running on with the operating system Ubuntu 20.04.1 LTS, and the processor in this system is quad-core Intel i5, and RAM is 8 GB. And you can use the alternative tools like Visual Studio Community Edition for Windows and Mac, or you can install GCC in Mac. You can also use online tool available in that link. So we will just see how these tools looks like, and we will start writing the programs. These are all the right sides things. Using these commands we will see how the tools looks like, and we will confirm the tools now by in practical way. I opened the Visual Studio editor in this system. You can see this is how it looks. So you can open a folder by clicking on the file, and you can click on the open folder to open the folder. So I have already opened the C programming folder. You can see here. We will see the version of this Visual Studio Code by clicking on the help and about. You can see this is the version of the Visual Studio Code 1.1669.0, and you can see the commit. This is the commit ID from the GitHub or wherever this source control versioning control system. This is the commit ID. So this is the final commit ID number provided by Git. That is a software configuration management tool. This is the final commit ID for this version of the release. Then date is the last updated in this system by this tool. This Electron version, it is the framework used to build the VS Code software. You can see the Chromium version used by VS Code application to run in this system. You can see Node.js, V8 and OS. Node.js and V8 are used by this VS Code respectively, means this version of the Node.js and this version of Chrome V8 engine. This OS is Linux x86 x64 5.13.0.52-generic. This is the Linux kernel version. This is the OS we are using in this system. Just I click on the OK. Now I opened the terminal. This we can see now GCC version, GCC space hyphen version. This is the GCC version we are using, 9.4.0. This is already installed in this system. GCC is GNU project, C and C++ compiler. We can see the documentation of GCC by writing man GCC command. You can see the documentation of the GCC. Yes, we can type Q to come out of the man page. Now we will see the operating system details. Like this is Ubuntu operating system, right? We'll see that through commands itself. Uname -r, uname -v. Just will type uname -help. So this uname -r will give the kernel release. You can see here. This is nothing but the kernel release 5.313.0 -52 generic, and -v give the kernel version. This is Ubuntu 20.041 LTS Ubuntu, and this is the date on which this kernel version released. If you want to visit all at once, you can name -a. This is nothing but this Linux is kernel name, and Sky Lenovo, this is a network node name, means host name of this system is -r kernel release, right? Whatever we have seen there, this is the kernel release, kernel version. This is the whole thing till this date. Then machine x86 64-bit processor, and this is the hardware platform. This is the operating system, Linux operating system. Now we'll see the processor details. For that, we'll just use the cat /proc/CPU info. So you can see here, these are all the details about the CPU. We'll go to the top. So this is processor 0, means we discussed, right? It's a quad core processor 0, 1, 2, 3, like that. So this is vendor is genuine Intel vendor. This is the model name Core i5 4210. This is a speed clock speed 1.70 gigahertz. So we have this quad core. So processor 0, processor 1, number 2 and 3. So total 4 quad core processor, and these are all the details about each core. So now we have seen the processor details. Yeah, proc file system is a special file system in Unix-like operating systems. It presents processor information and system information in a hierarchical file structure. Now we'll see the memory related information. For that, we'll do the cat/proc, then meminfo. So this is the memory RAM information, main memory. So these are all like how many bytes total, free, available buffers, pagination, all these aspects related to RAM is available with this command. So totally 8 GB. So it's this, with this byte it comes around 8 GB. We covered the tools part of it. Now we move on to write, compile, run a program. So we will write the hello world program in hello world.c file. We'll compile using that gcc space -world hello world.c file, and we'll run with the ./a.out. So a.out is nothing but assembler and link editor output format. So we'll quickly move on to, we'll write the program, compile it and run it, and we'll see the result. Okay, this is the C programming folder. Here we will create a new file, hello world.c. Just click on enter. I will see hello world.c file. I just copy pasted the code, whatever it is there in that slide. It is shown, it is copy pasted here, and if you see here white dot bubble, it's not saved yet. Just I will do Control S to save this file. It's saved now. Now you can see the program like if you see, you can see here these are all comments. This is a multi-line comments where slash and star, and it ends with the star and backslash. So this is totally multi-line comments. Then here it is a single line comment we used, means hash include stdio. We don't know much about what is this actually, but this is only to do write a multi-line comment. This is the thing, and to make it one line comment, this is the syntax that we will see later. Here this is a simple code, right? So this is like a main total program, simple program, which here main you can see it is actually a function. We have not come across this things till now, but we saw int as a data type. Here what it means is we don't know till now, till this point. Int is but we know that int is a data type and it's a keyword used by C language. So for now at time being, I will just tell this one. Main is a function here, and this is the entry point, and to identify this function, these brackets like left and right brackets shows that it's a main is an identifier which is a function, and it returns an integer. So these are all separators. We have not seen much about the separators, the brackets as well as these braces, parenthesis. So here you can see this printf and hello world. So this one is a string constant. We know, we come across this string constants. Hello world, there is a space here because in the string constants space is allowed. Here all the white space is ignored by the compiler. So here printf is to print this hello world string. So this is a built-in function or a standard C library function. So for now we'll be just using that printf. Actually what it does, we don't know much about it now. And there is a return which returns this value. Currently 0 we are returning. So this is about the source code. So this program and it needs to output 0 on success, but it has to print the hello world whenever we run this program. So here it is a .c file. It's a source code because it's a human readable form. So it is a C code. That's why actually Visual Code Editor is going to identify these things. If we just make it like instead of changing this .c to just remove this, make it as a text file, you can see you don't see that all the color, like whatever the color it has shown, and it is not showing as a C file also because it's a text file now. Just we'll make it, rename it to a C file now. So this is the extension .c file. Now it shows that it is a comment. This is in the different colors. So this is about the source code. Now we'll go to the compilation part. I'm just opening a terminal. I'm going to our directory, CD2, that C programming directory. Now the command to compile. Just think now it's a totally compilation. Compiling that hello world.c file. Hello world.c. Just I click the tab, so it will show that whatever the file is available there in Linux environment. So now just I will run it now. Yeah, there is a warning. uh, Actually there is a hash include required to provide the declaration of printf. This is what warning, but actually that why that warning, and just leave the warning for now, but we will make in the subsequent session itself. In the same session we'll try to remove this warning by seeing this what are the note it has provided. Now we'll see what are all the files it's created here. There is a command ls to see the files. Now you can see a.out. Here also you can see in the visual code editor there is a a.out key generated, but here we'll see in the terminal. This is what link and assembled and link editor file. As we saw, this is an executable file. Now we will run our command ./a.out. So this / is the dot means it is to tell that this is current directory. In the current directory a.out. So we are going to execute this file a.out, which is there in the current directory. So now you can see hello world. This is the output from this a.out file. So we created a file in the visual code editor, we compiled it, and we ran it. Now we saw the output as well. So this is how we will run the write, compile and run the program. Now we'll see the intrinsic part of the compilation process, actually how it has generated this a.out. Step by step we'll see now. Yeah, we saw write, compile and run a program. Now we'll move on to compilation process. So this is actually steps inside the compilation process. So there's the first step is preprocessor, second step compiler, then assembler, linker, loader. Preprocessor means when in this step any preprocessing directives or hash includes, and these are all the things are substituted and created another intermediate file like a dot with the extension .i. This is about the pre-processing stage. Then there is a compilation stage. In this stage it will take this whatever the pre-processed output file, it will compile it, means do the lexical analysis, tokenize that total source code file and parse it, apply the grammar rules, then generate the assembly output. So assembly output is whatever the system processor which is running in the system, that system assembly level languages instructions will be generated. That is the output of the compiler. Then is assembler. So the output from the compiler goes to assembler. In this assembler process it will generate the object file, means it's actually generate the machine level code from the assembly language code which is generated by the compiler. Once it is passed, it will whatever that it generated, next a linker. Like here we are seeing this hello world dot only one file, hello world.c, and it is converted to hello world.o. But if in a big program or a big project, we will have so many files. So it will be individually compiled and as object files generated, then it will link in this phase to make it as a single program. This program is, you know the program, right? It is totally a set of instructions which a computer can understand. So this will, a linker will assemble, it will link all the object files and create one binary in the executable form. Then loader comes into picture. It's actually while running the program. So we created that whole as an executable file. When we are invoking that, when we are doing that slash a dot out, right, at that time actually it needs to load into the memory RAM. Then it needs to execute from the main program. Wherever the main function is there, it will start executing from there. Okay, with this background we'll see how that files looks in each stage. Now we'll see the generating the output from the preprocessor. So that is, there is a, let's just see the first how this GCC help looks. You can see here GCC, there are different options for this GCC. So there is a save temps, do not delete intermediate files. We will see later with this option also. First we will see this option, preprocess only, and do not compile, assemble or link. So this is only a preprocess. Do not compile, assemble or link. So with this option we should be able to see our output like this. So we are 1 minute. You can see like we are giving the input hello world.c, preprocess it, and we need to compiler will generate, or preprocessor will generate hello world.i. That will see how it looks. GCC hyphen capital E hello world dot c. It just will run how it looks. Actually it has pre-processed, but it has given the output on the screen itself. But what we will do, there is an option to output the file. What is the option? If you provide that -o file name, it places the output into the file. So we will use this -o option. Just I'm clearing this. GCC -o. They are telling that it is a extension of hello world.i. So just it's actually writing that whatever that pre-processed output file into I. Now you can see ls here, you can see the .i file. So what is currently it has done? It has taken this .c file and it has generated the hello world.i. This is by the pre-processing stage. Now we'll see in the editor. Here you can see that hello world.i. You can see here like this is the int main print of hello world return 0. This is the same source code which is there in the .c, but you can see here there is a different things which has generated by the preprocessor itself. So now this you can see hello world.c built-in command line, and this one it is actually done by the preprocessor itself. It's a compiler itself inbuilt. So that's why it's a built-in. It's showing that built-in, and this is user include stdc defs.diff.h. This is one header file. It is taking from here. It is adding to here. So now we'll see that user include stdc-predef.h file, how it looks. So just I'm opening in the editor, copied that one line, this one. It looks like this header file. So here it is showing that it is telling that this header is separate from features.h, so that the compiler can include it implicitly at start of every compilation. So it is implicit, and at the start of every compilation it will include. That's why we are seeing in that file. Now I am just deleting this .i file. Then we'll see the next stage. So I deleted .i file now. Now we deleted the dot file, right? Now we'll see now hello world data is not there. Now we'll see the only till compile only option and do not assemble or link. So there is a hyphen s option we have to use. So just I am clearing now. So gcc hyphen s hello world.c. So this with this now it needs to generate hello world.s file. So how it looks means, so we are giving the hello world.c as an input file. So internally it invokes a preprocessor. Intermediate file hello world.i it will generate and it will pass it to the compiler. Then compiler will need to generate the hello world.s. This is the thing it needs to be done now. Just will come out of this option of print. Then we'll run this command now. Yeah, these are all the warnings. We know this warning will come. So now we'll see what is the generated hello world.s. You can see now this .s file is generated. Here also you can see in that Visual Studio Code, Visual Code, I will open that hello world.s. Yeah, this is the generated assembly code from the compiler stage. So there is a RO data section, read only data. This is a .text. Text is nothing but for the instructions or the program. Then you can see here like main and what are the different sections, and this is a global main, and this is a constant, so read only data, right? It is a constant. You can see hello world, and this is a global main is a function type. These are all about the actually header information or the details about what are all the entry points or functions. So you can see here this all the code here, printf, what internally it will do. So this these are all registers and these are all machine code, assembly code of this processor x86 64-bit Intel i5 processor assembly instructions. So this is how it looks, the assembly code. Now we saw the root processor and this compiler phase. Then we will move on to the linker, assembler. So it needs to generate a .o file. Now we'll delete the .s file and see deleted, go to trash. Now we'll see the next step of assembler. So we are going to give the input as hello world.c. Finally it needs to give me a minute. Yeah, now we'll see the assembler output. We are going to give the hello world.c as an input to the preprocessor, and it will give the it will goes to compiler next assembler. So this assembler give the output as hello world.o. That we will see now. We'll see gcc help again. Here this option to -c compile and assemble, but do not link. So this is the option we are going to use it now for the, if you see -c hello world dot c. Now there is a warning, just I'm clearing to make it. Now we can see hello world.o. Try to open here. Yeah, if you see here, the file is not displayed in the editor because it is either binary or uses an unsupported text encoding. So this is a binary file. So these files and file formats we'll see in the next step. So this is about the .o. It has generated the .o file. So to read this .o file, we will see how this file format can be opened later after this completion of the other stage as well. So now this .o is created. Now if you with that is the output of the assembler. So there is a linker stage as well, right? Now we'll see how that linker behaves. So this is how. So assembler will give the output, means its object file hello world.o. So let us take the case. We have written some more people counting our use case study, and we created one more file, separate file for it, and we generated a .o object file from the assembler for that specific file people count.c. So in this case we want to link these two files and create one executable file. So this hello world.o and people count.o will be an input for the linker, and it will generate the a.out. So in this case we just we created the hello world.o, right? What we'll do, we'll try to invoke the linker directly with the .o. Yeah, currently we are not giving the people count.o because we have not created that one. When we comes to a situation where we created that file, and we will see at that time how these two files can be linked. But for now, what we will do, instead of invoking all this process, we'll just invoke only with the .o file itself. They will see whether it will generate the a.out or not. So for this, we will just come out of this presentation thing. Okay, I will delete this a.out. Okay, now we'll see only .o is there. We'll see gcc option, gcc with hello world .o. What it will do? Oh, it has actually done this process. Now we'll see, you can see the a.out. Then we'll run now this a.out. Yeah, you can see the hello world. So you are given directly the a.o file, and it has created the a.out itself. This is what the job of the linker. Now we'll see what is loader. What is the functionality of loader? So you can see all the pre-process, compiler, assembler, linker, all these steps are comes under compile time. So means when we are invoking the GCC, these are all it is a total compilation process. But in case of a loader, it is not at the compile time. It is actually a runtime. Means when we are invoking that program, that is a.out, /a.out, we are invoking the loader. It will load this a.out file using that sections like a data section uh, uh, code section. It is also like a dot text section, and uninitialized variable section. And if any shared libraries, if it is using by the program, it will load all the things. So the shared library in the sense, it's a library of functions or functionality which is available in the system. It can be used for any program. So in that way, it should be loaded to the system to execute the program. So this a dot out is loaded to the system, then it will execute and it will give the output here. This is the whole runtime. So whenever you see the compile time and runtime, this is the difference. So when you are compiling, you will get the compiler errors, like warnings we saw, right? Or if anything goes wrong in the compilation steps, you will see the compile time errors. These runtime errors are majorly when you are running the application. So when the program is getting run in the system. So this is the difference between the compile time and the runtime. So now we have seen all the stages of compilation as well as the loader or the runtime. Now we will see each file formats one by one, and what exactly the file, because we have not seen the .o file contents, and what is this ELF format. Yeah, now we'll delete this .o file from here. Just deleting. Go to trash. Then we'll use another way of generating all the files at once. That is gcc -help. Now there is option save temps. This we will run this command. Save temps. Hello world.c. Now you can see .i file, .s file, .o file is and .out all are generated with this command, with the option of the save temps. So with only this using the save temps, we can generate all the intermediate files at once. So this is one way you can see. Okay, before going to the file formats, we'll see how we can eliminate this warning. So this is an implicit declaration of function printf. So it can be warning can be include this printf in the file. Okay, what we'll do, we'll go to this .c file and just will uncomment this lines. So now you can see #include stdio.h, and we'll save this file. Then we'll run this command again here. Okay, now we ran this one. So now we'll see the .i file here. You can see now it is now very big. .i, it is after pre-processing stage. So you can see our last this hello world C program here, whatever we have written that hello world name, but you can see all these things which comes from the #include printf, #include stdio.h. You can see this warning, there is no warning now because we included the .c file. Sorry, we included the .h file, which because of that one we are getting the warning. So you can see this #include stdio.h, and this is the pre-processing. So finally you can run this command. You don't see any difference in the output. Yeah. So this is about some intermediate options which will give saves the intermediate files as well. Now we will see the file formats. We saw that all the compilation process and what are the intermediate files we are getting. Now we will see the file formats. How we can see .c, .i, .s and .o extensions and the a.out. So this is like a ELF file format. If you see the .o, it's a binary form, right? So that is a executable and linkable format. It is a common file format for executable object files and shared libraries and code dumps. So this is the command. We can see how this one looks. We will disassemble this hello world.o now. Okay, we'll just move on to here. I'm just clearing here and obj dump -d hello.o. Now you can see this is the different sections or the you can see this hello world.o file format ELF64. This is of type file type ELF64. And there is another way you can see the what is the file type hello world.o. You can see this is hello world.o ELF64 bit LSB relocatable x86 64 version 1. This is a file type. You can see the .c as well, hello world.c. Yeah, this is a C source ASCII text. What is this I? This is also C source ASCII text. We'll see what is the file type of a.out. Yeah, you can see this is also ELF 64-bit LSB shared object x86 64 version dynamically linked interpreter. You can see this is actually this SO shared object is required for these files. So this is nothing but what is this whole program a.out. So but here it is not loaded yet, this .so, but it is depending on this SO file, shared object file. So this is about the file types we can see, and you can see here .o file how it looks, and we can do the object dump of a.out as well. We just do append. Yeah, you can see whole a.out dump. So it's that whole executable a.out. This hello world.o is only object file for only hello world.c, but here this is whole executable which is required to load in the system and it will be executed or it will be run. So these are all the different sections, and you can see what is the hexadecimal code for it. So there is a dump also, hexadump -cn 332 some size we can specify, and we can see the hexa format hexdump -c -n. Just I am saying only 32 bytes and a.out. You can see this here 16 bytes and 16 bytes, total 32 bytes. This is of type ELF. This is a magic number they call for the file format. So these are all about the file formats, and you can see LDD a.out. So this is of type this is depending on these shared objects. So you can see man hexdump, what actually hexdump will give. This is a ASCII decimal octal dump. This is a utility which displays the specified files, and standard which displays the specified files. These are all the different options with the hexdump. We can see man LDD as well. This is a print shared object dependencies. So like LDD of a.out is having the dependency on these shared objects. So this is about the file formats and how we can see the dump of it in the C programming. Yeah, now we can see this -x option as well, that is for the headers. obj dump -x hello world. Sorry, obj is extra. Yeah, these are all the different sections. It's a start address, and this is the sections. Text data section we discussed, right? VSS, it is for uninitialized data, read-only data. These are all some comment frames which is specific to GNU, but these are all the main sections: text data, VSS, RO data, and data. So these are all the different sections, and we can see for the a dot out as well what is having that a dot out as well. Oh, this is the different sections for here. Yeah, this is a file format ELF64 x86 64. This is the architecture for which this executable is created, and this is start address. Now you can see the difference. There it is showing 00. Now it is linked, all the linked ones. So this address will change, start address, because it actually includes some implicit files which are required to run this program. So that we can see in the later sessions what are all those files, but these are all the program headers, like which is important. When the loader comes into picture, it reads this file and it uses these sections, different sections, and it loads into the system according to that address. You can see different sections. Symbol table, yeah, this is an important one. Symbol table, like when the compilation phase, what are all the each tokens while doing this compilation process, means when it is reading the file and it is forming the tokens and parsing that grammar. So that we will see in the later sections a little bit more in the what happens with the .c file internally when we are looking at the identifiers, data types practically in the session, in the later sessions. So, but you can see the symbol table and different sections in this a.out file. And now we'll see some stats. It's just a generic one. Practice increases confidence by 100%. This is one stat, because today we started the practical sessions, right? Then this practice. That's what the programming means. Yeah, this is one quote. The only way to learn a new programming language by writing programs in it. This is from our Kernighan and Ritchie itself, from that book. This is an important quote. This is one takeaway. Write, compile, running program practically boosts the confidence. So that's what today we saw. What is the writing, compiling, running, what is the compile time, what is runtime, and what are all the different intermediate files in each stage of the compilation process. Thank you.